So guys, welcome to our channel once again. In today's video on our WAEC physics exam revision series, we have here these 9 repeated questions to answer on the topic motion. So this video will be about motion under gravity. So in short, stay till the end of this video. Let's go ahead and start with the first question here. It says, a body of mass 20 grams projected vertically upwards in vacuum returns to the point of projection after 1.2 seconds. Calculate the speed of the projection. So guys, here let's note that the time here, 1.2 seconds, is the total time taken for the entire flight, and that's capital T. And in order for us to know the time taken to reach the maximum height, that is the small t, and that's equal to this total time over 2, and that's 1.2 seconds over 2, and that's 0.6 seconds. So t is 0.6 seconds, and then the mass here is in gram, and that's 20 grams. If we want to convert it to kilogram, that would be 20 over 1000, that's 0.02 kilograms. So guys, we also have the acceleration due to gravity here as 10 meter per second. Alright, so guys, if we want to find the maximum height of this projection, we're going to use the formula T is equal to root 2h over g. So guys, if we square both sides, we're going to have t squared is equal to 2h over g, and if we make h the subject of this equation, we're going to have that gt squared over 2 is equal to h, or h is equal to gt squared over 2. So guys, our g here is 10, then our t squared is 0.6 squared. 0.6 squared is 0.36, and 0.36 times 10 is 3.6, and 3.6 over 2 is 1.8. So that's it here. 1.8. H is actually 1.8 meters here. So in order for us now to know the velocity, we know that the body actually moved and then had a potential energy that was converted to a kinetic energy. So here we are going to have that the potential energy is equal to the kinetic energy. So kinetic energy half mv squared is equal to the potential energy mgh. So in that case, if we equate these two, half mv squared is equal to mgh, or we say mv squared over 2 is equal to mgh. So in that case, if we make v squared the subject of this equation, we can go ahead and cancel out m, and then we'll have v squared is actually 2gh. So if v squared is 2gh, what's g and what's h? So v squared is going to be 2 times the g, which is 10, times the h, which is 1.8. So in that case, v squared is 20 times 1.8, so that's 36. So v alone now becomes root of 36, and that's 6, guys. That's option C here, 6.0 meter per second. And that's it for this question. Let's go ahead and consider the next question, guys. So the next question here, question number 2, says a ball bearing is projected vertically upwards from the ground with a velocity of 15 meters per second. Calculate the time taken by the ball to return to the ground. So guys, if we go ahead and use v is equal to u minus at here, we have that the acceleration here due to gravity is 10 meter per second, then our v here is the final velocity, which is actually 0 in this case, and then our u is the initial velocity which the ball went with, that's 15 meter per second. So if we use this here, we're going to have that v is equal to u minus 80, and in that case, if we make t the subject of this equation, it becomes v minus u over a. So let's note that this becomes v minus u over negative a. So in that case, we have 0 minus 15 over negative 10, and that's negative 15 over negative 10. So if we cancel out here, we'll have t to be 1.5. But guys, that's the time taken for the ball to reach the maximum height, and the total time that will be taken for the ball bearing to return to the ground will be 2t. So that's 2 times 1.5, and that's 3 seconds. So option B is the answer to this question, guys. Let's go ahead and consider the next question. So guys, the next question here is question number 3. It says, a ball is dropped from the top of a tower. Due to air resistance, it reaches terminal velocity. Which of the following statements about its motion is/are correct? We have I, the acceleration of the ball is 0. I, the net force on the ball is 0. I, the velocity of the ball increases. So guys, option A is I only, option B is I and I only, option C is I and I only, option D is I and I only. So guys, the answer to this question is option D, I and I only. So let's go ahead and consider the next question, guys. So the next question here is question number 4. It says the area under a velocity time graph represents A, distance covered, B, work done, C, acceleration, and D, final velocity attained. So guys, the area under a graph is multiplying the y-axis by the x-axis. So guys, here we have velocity time graph. A velocity time graph has velocity on the y-axis and time on the x-axis. So if we multiply velocity by time, we're going to have displacement, which is the distance covered here in a specific direction. So that's option A here. Option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 5. It says, a body is projected vertically upwards with a speed of 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. Alright, so guys, since the body is projected from a distance that is 2 meters above the ground, so let's see the maximum height of these objects from these points. So that would be u squared over 2g. So u squared is actually the square of the velocity here, that's 10 squared, then over 2g, which is 2 times the acceleration, that's 2 times 10. So u squared here is 100, and then 2g is 20. So 100 over 20 now becomes 5. So the h here is 5 meters. So guys, it means that for it to reach ground again, it will take 5 plus 2 meters, that's 7 meters. So let's take note of these two. Now to calculate the total time it will take to come down, we'll calculate first of all the total time it will take to reach the maximum height, and then the total time it will take to reach the ground. So for the total time it takes to reach the maximum height, t is equal to root 2h over g. So in that case, 2h is 2 times 5, then g is 10. So root 2h is actually root 10 over the g, which is 10. So that's root 1 and that's 1. Now for the time it will take to reach the ground, we'll go again. T is equal to root 2h over g. But here now the h now becomes 7. So 2h is now 14. Root 14 over 10 is root 1.4, and that's 1.18. So guys, to get the total time, we'll add the time taken to reach the maximum height to the time taken to reach the ground. So that will be 2.18. So guys, option D is the answer to this question. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 6. It says, two blocks of the same dimensions, one steel and the other wooden, are dropped simultaneously from the same height. If they fall freely, neglecting air resistance, the A wooden block, being lighter than the steel block, reaches the ground first. B steel block reaches the ground first because it is denser than the wooden block. C two blocks reach the ground at the same time because the dimensions are the same. D two blocks hit the ground simultaneously because they have the same acceleration. So guys, option D is the answer to this question, and that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 7. It says, which of the following graphs describes a body that accelerates uniformly with an initial velocity greater than 0? So guys, we have different graphs here, but option B here is the graph that best illustrates a body accelerating uniformly with an initial velocity greater than 0. So let's take note that this body accelerating uniformly with an initial velocity greater than 0 means that a change in velocity leads to a change in the time. So, and the initial velocity here. So you see that the only graph that illustrates this is the graph in B. You see the graph starting from a point on the y-axis greater than 0, and then increase in velocity leads to an increase in time as well. So option B is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 8. It says, a bullet fired vertically upwards reaches a height of 50 meters. Neglecting air resistance, calculate the magnitude of the initial velocity of the bullet. So guys, we have g as 10 meters per second squared. So if we go ahead and take that the kinetic energy here is converted to potential energy, and we equate the kinetic energy half mv squared to the potential energy, which is mgh. We go ahead and solve for the velocity by, first of all, eliminating the mass, which is common between the two. So we cancel out the mass here, and then to find velocity, we make velocity the subject of this equation. So where v squared is equal to 2gh. So guys, there is a little systemic error here. So the height here is actually 500 meters and not 50 meters. So it reaches a height of 500 meters. So 2gh here is going to be 2 times 10 times 500. And that's 10,000, guys. So we'll go ahead and find v here as the square root of 10,000, and that will give us 100. So that's 100 meters per second, and that's it for this question, option C. So let's go ahead and consider the next question, guys, and that's the last. So the last question here, question number 9, says, a body dropped from a certain height above the ground level falls with uniform A, speed, B, velocity, C, retardation, D, acceleration. So guys, the answer to the question here is acceleration. A body dropped from a certain height above the ground level falls with uniform acceleration. So that's it for this video, guys, and this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community where we post major updates on WAEC examination. So guys, this will help you a lot even as you study for your WAEC examination for the year. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.